Welcome to the day 5, second session, Artificial Intelligence, Knowledge Representation. The speaker is Dr. Hanumanthapayam, Professor, Department of Computer Science, Bangalore University. So I request all the participants, so I'm just add up here and we will share the feedback after some time. So we can start the session, sir.
Okay, shall I continue, sir?
Yes, sir.
Okay, good afternoon to all the participants. I hope all of you had a nice lunch. I think it is not the virtual lunch, it is actual lunch what you had, I think. Normally, after having a nice lunch, it is very difficult to sit for a session of 1.5 hours to 2 hours. But here, I don't make you to sleep. And moreover, it is a virtual, that is a webinar online. So we may not be knowing what you people are going to do. But I will try to make it live as much as possible. And I expect it is to be more interactive session than just one-way delivery. That is the disadvantage of this online classes or online sessions or online webinar, whatever we're going to do. It is just a one-way delivery most of the time. Even, but I will try to do my level best. Friends, morning we discussed about the AI and its the various aspects of artificial intelligence and applications, advantages, disadvantages, and its representation. Just as I mentioned in my morning session, that is internal representation. That is the most important one, as we are going to have without that creating the knowledge base, it is very difficult to make the system as an intelligent one. So that is as suppose if you want to do any automation or say that is in the case of database management system, something we say hotel management system, banking management system, like that, we used to use the database. And later on, when it comes to the mining, we used to use data warehouse. And now we are moving towards this artificial intelligence and this other machine learning, data science, etc. We have to, that is, it's all these things are called knowledge era. We have to use this knowledge base. Unless if you create an effective knowledge base, we may not be able to create an effective and efficient artificial intelligence entity. So that is creation of a knowledge base is very much important in all these aspects. And when it comes to the knowledge, there are various types of knowledge. We will discuss the different types of knowledge and its representation. Various entities, how it is going to actually work in the present scenario. And as one of the participants asked, one of the madam asked in the morning about the journals, that is free Scopus index journals. And also I will show you how to write the actual that is contents or a paper for this Scopus index journals. So I will try to cover as much as possible. And also I expect some kind of interaction. Friends, as I was telling that knowledge-based system. So once if you say the knowledge base, it is we are going to have the different types of knowledge which is going to be stored. And once if you store a particular type of knowledge, so normally we will be saying that he is good at mathematics, he is good at political science, he is good at economics, something like that we will be saying. And I mean to say that the particular person is going to have more knowledge about a particular topic. So we say that an expert. So normally the doctors are going to be experts. Again, in that there are going to be different domains. That is, one is heart surgeon, cardiologist, like that, the various. So here also, if you create a particular knowledge base, the system is going to be a expert system. So a system that can do a specific task with similar ability as human experts is going to be called as an expert system. So normally the expert system, in the sense that is as like human experts, say yes, I may be an expert in some topic and you may be an expert in some topic, something like that. So each one of us are going to be an expert in one or the other field, means we are going to have a kind complete knowledge about that uh, task. So then we will be called as an expert. So similarly, a system that can do a specific task with similar ability is going to be called as an expert system. So knowledge-based system, a framework to put domain knowledge in an expert system, is going to be called as knowledge-based system. So normally here the users are going to have an interface, and there will be a reasoning mechanism, and everything is going to be stored in the knowledge base. And the knowledge is going to be that is there are a knowledge acquisition mechanism, in the sense there are various ways of acquiring the knowledge. There are various ways of getting the knowledge and storing it in the knowledge base. As human beings, we are also going to have the different acquisition mechanisms. You may read a book and get the knowledge, and you may listen to a talk and you get the knowledge, and you may see and you may experience. So based on the various things, we are going to get the knowledge. So all those things are going to be called as knowledge acquisition mechanism. So this comes from the world. That means from the environment, from the different people, from the different tasks which we are going to do. So this is the knowledge base which we are going to create. So we will see that knowledge base, how to create and how to represent. So again, in the knowledge base, so as we have seen in the database, how do we store? We store the data in the form of tables. So here, how we are going to store the knowledge base. So that we will see. So knowledge base, a formal description of facts and rules of the problem solving domain. So it's we are going to describe, or there's a formal description of facts and rules. So for each and every problem, there will be a facts and rules. Or even if you say any task or anything, there will be some facts and there will be some rules. So those facts and rules are going to be described in the formal way. So that is going to be used in the problem solving. So that is going to be create a norm that this one knowledge base. A set of formal data structures are going to be used, something to get the reasoning mechanism going on. So that means here we are going to have the set of rules, and which are going, the facts are going to be stored in the form of set of rules, and those are going to be stored in a set of formal data structures. And for that, there will be a reasoning mechanism. So all these three put together is going to be the knowledge base. So when you're going to create the knowledge base, what are the things which we consider? What are the things that is what is good about a knowledge base? So like when you're going to say about the database, what is the good about a database? So the database must be a normalized one. So we have studied the first normal form, second normal form, third normal form, something like that. So here also, when you're going to create the knowledge base, so we need to have some kind of permanence and consistency. So that is permanence is the preserve important knowledge. That means it's going to store that whatever the knowledge we are going to store in a knowledge base must be permanent in nature. So it is not that today it's correct and tomorrow it's not. It may be wrong. So we should not have that kind of knowledge. Always we should be a complete. It is permanent knowledge. So that is preserve important knowledge and consistency. Solutions do not change. That is whatever the knowledge we are going to have. So I mean to say that say simple example for this. All of us know multiplication tables, is it not? The multiplication tables is also a knowledge what we have. which is very much required for the mathematics. So that always it's a permanent. That means we cannot whatever we learned and studied at our primary school, even today we are remembering, and it's always consistent, which cannot be changed. It's not going to be changed. And what is bad about knowledge base? That is no common sense. So that is can only be used for a specific task, not human. That is like how we are going to have the human beings. There won't be any flexibility, no adaptability, no creativity. Just whatever it's like just whatever we have stored, it's going to be stored in that knowledge. Always the morning also we discussed about this. There won't be any flexibility, adaptability, and creativity. So knowledge base is going to consist of three things: the formal data structure, formal rules, and reasoning mechanism. And whatever the knowledge base we are going to create must be permanent in nature, and this must be consistent. And normally, we cannot store the common sense knowledge. What is common sense? So suppose if somebody has somebody fallen or somebody is dead, and we cannot go in front of the body and dead body, and we cannot laugh. Is it not that people say that you don't have the common sense, even though if he is your enemy or whatever it may be? So we have to show this one. That is the kind of common sense. And as human beings, we don't. As human beings, always we will be having some kind of flexibility. Always we are going to have some kind of adaptability. So suppose assume that today one of your friend or enemy or not enemy, somebody where you may have an impression or perception that that person is a bad person, and after 2 3 days you may come to a conclusion that he is also a good person, so that you can adapt or you can change your this one. But whereas when it comes to the system, that is knowledge base what you are going to create in the computers, it is highly difficult to change. That is adaptability, and there won't be any creativity. So that is knowledge base. And how this knowledge processing phases are going to be. Knowledge processing phases. So knowledge representation, knowledge utilization, knowledge acquisition, and how we are going to refine that knowledge. So we'll see all those things. Knowledge representation. There are various knowledge representation techniques. Formal representation of domain knowledge. So suppose if you are going to say that, assume that my color of my shirt is red or color of my car is white. So it is a sentence, it is a fact, it is how do we store this in the knowledge base? What kind of logic we are going to use? What kind of production rules we are going to use? What is the semantic? What is the syntax, frame, formal logic, and all those things we are going to use? So need to be so that's going to be called as knowledge representation. Once if you say that knowledge representation, there are different types of knowledge representation techniques. One is production rules, semantic network, and the frame structure and formal logic. So I hope all of you know this formal logic which we have studied. Normally we will be studying in this maths one, that is discrete mathematics, set theory, and all those things. And the frame, each and everything is going to be put in the form of a particular frame, which is easy, which is going to be easy to represent and store. And semantic network, it's also a graphical representation. Production rules, there will be various, it's like an algorithm which we are going to write as a step-by-step method. And once if you create this knowledge base and represent the knowledge base, how to utilize that knowledge, that is called knowledge utilization. Reasoning mechanism. So once if you say the reasoning mechanism, that means the reason for particular action. So there are deduction, induction, and abduction, hypothetical reasoning, analogical reasoning. So all these the various types of reasoning mechanisms which are going to be included or which are related to this knowledge base and highly related to knowledge representation. We can say that these things are like an SQL statements in the this one. So how we are going to select the data by using the it's all those things are the SQL statements. Like here also we are going to have the different deduction of induction, abduction mechanisms, so that we are going to extract the knowledge and we are going to make use of that that is manipulation of the knowledge or utilization of the knowledge. And it highly related to the knowledge representation. That means how best your how what knowledge representation techniques you have used. Based on that, you can utilize the knowledge. And knowledge acquisition and refinement, as I have shown you in the beginning, that is stuck in this one. Knowledge acquisition mechanism, how that is reasoning mechanism, we have seen interface, and this one acquisition mechanism. What are the different acquisition? That is interview with experts. Normally, when you interact with the experts or the people, we are going to get some kind of knowledge. And also say based on their interaction, and also you can improve that, or you can refine that this one. And how to manage the huge amount of knowledge, that is also a bottleneck. So, and for that there are various techniques like machine learning, how to make the system to learn all those things and make the knowledge as a refined one. So that is all related to this knowledge processing phases. So there are, as I was telling, that there are different types of knowledge. We are going to consider all these are the different types of knowledge: expert knowledge, common sense knowledge, and there are various types: the expert knowledge and common sense knowledge, declarative knowledge, procedural knowledge, heuristic knowledge, theoretical knowledge, domain knowledge, task knowledge, complete knowledge, incomplete knowledge. So like this, there are various types of knowledge. What is expert knowledge? The knowledge that an expert uses to solve a problem is going to be called as expert knowledge. And normally it is going to be task or domain specific. It is the knowledge which is related to a particular task. So suppose if a mechanic, if he is going to, if he is an expert in doing repair of a particular bike or a moped, so then it's a task or domain specific. And a doctor also may be good at whatever the cardiologist or was like that. Difficult to understand for non-experts. Normally, whatever the expert is going to do, it may be difficult to understand for non-experts and easy to capture in rules. So that means why? Because it is normally the production rules are going to be used for this expert knowledge. So it is the whatever the expert knowledge is going to have a certain rules and regulations. So it is easy to capture in the form of rules. And common sense knowledge, that is as a kind of knowledge which we are going to have as human beings. I hope all of you are going to have this expert knowledge. All of us are going to be an expert in one or the other task. And somebody may be good at cooking, somebody may be good at painting, somebody may be good at playing chess, something like that. So each and everything is going to have some rules. So and it's easy to store it in this one. And common sense knowledge independent from the task or domain. Common sense, as just now I was telling that, what is so as all of us are human beings, we have the common sense knowledge. And how to create that common sense knowledge base, that is very difficult sometimes, independent from the task and domain. High level of abstraction, difficult to capture in rules. So that's the because it is difficult to capture in the form of rules, it is highly difficult to store it in the system. And a high level of abstraction, that means the perception, the common sense which we exhibit is different from different people. So there won't be any rules and regulations for that. So it is independent from the task or domain. And next, that is knowledge is declarative knowledge and procedural knowledge. Normally, the declarative knowledge, whatever we are going to have, is what. So normally, even the suppose whatever the knowledge we have, so it's of a kind of definition type. So all those things are going to be called as declarative knowledge. So we may have a definition of artificial intelligence. We may have a definition, say, the general knowledge, whatever we are going to have. Who is the Prime Minister of India? Who is the Chief Minister of Karnataka? Who is the President of India? Something like that. So all those things are going to be called as declarative knowledge. And the procedural knowledge, that is how. So that means the reason behind that declarative is going to be called as procedural knowledge, how we are going to do that. So suppose assume that there is an example, there is a way to get from this our campus, that is Gnanabharati campus to Central College, from one place to other place. So how we are going to, that is declarative knowledge, and so how we are going to, what is the way is declarative, and how we are going to solve that is going to be the procedural knowledge. So that means take the bicycle to the station and then take the bus to, so that is called the procedural knowledge. And we are also going to have the heuristic knowledge or shallow knowledge. Normally, what do you mean by an heuristic? I hope all of you know this. Heuristic. What is the meaning of heuristic? Heuristic means extra knowledge. That is extra information. So normally the extra information or the extra knowledge is going to be called as the heuristic knowledge. I think most of you might be knowing the heuristic search or heuristic search techniques. So that means, for example, if you say that heuristic extra information, assume that you are searching for a house or address in a locality in a place called Bangalore, in a area called Jayanagar. Suppose assume that you have a address number 21, first cross, Jayanagar, fourth block, something like that. So you need, and if you have an heuristic knowledge means, or heuristic information means, say suppose if they mention that the number of floors in that building is 4 floors and the color of building is pink, then we need not search from 1 to 21. Just directly we can see what are the buildings which are having 4 floors and the pink color. Directly we can go to that building. So that is the extra information. That is the extra knowledge. So that knowledge is going to be heuristic knowledge or shallow knowledge. So it is always, it is not going to be complete, but usually holds. As I was telling that it's only an extra information based which is going to help or which is going to reduce the search space, and it's going to be based on the experience, and always it's going to be individual, and it's not specific and non-logical, and it's going to be informal. So whatever you are going to say suppose if you say something, it is not, it may or may not be logical. Use directly for problem solving or to improve the efficiency of the problem solving process. So suppose if you say that an example, when the engine makes a sound A, part B could be broken or may not be. So normally when you are using a, suppose if you are using a bike or something, if it is not starting, what we will do, we will check the spark plug. So maybe that is one of the reason. It's not that that is the only reason. So there may not be the petrol or there may be battery there, something like that. But normally when the engine is not starting means directly we will check for the spark plug. So like that, that is called heuristic or the knowledge what we are going to have. So this is also, we have to create all these types of knowledge into the system. Then only it is going to be an artificial intelligence entity. And theoretical knowledge or deep knowledge, that is also one of the knowledge type. Theoretical or deep knowledge, the mathematical or logical knowledge behind the problem domain, usually combined with heuristic knowledge in problem solving. And always it's going to be model-based reasoning, object model, causal networks are going to be used to represent this type of knowledge, theoretical knowledge. So suppose if you are going to have some kind of theorem, or if you are going to have some kind of whatever the proof and other things, so that is theoretical knowledge, we are going to say. Normally, if it's going to be combined with the heuristic knowledge to solve a particular problem. And we also have a type of knowledge called domain knowledge. Say knowledge characteristics of the problem domain. So that means a specific or particular knowledge is going to be called as domain knowledge. So medical knowledge, say the doctor, whatever the knowledge is going to have, it's domain knowledge. Task knowledge, knowledge used for problems, for the problem solving process. So that means knowledge characteristics of, say, suppose it can be a medical or it can be an insurance or it can be a banking knowledge or financial domain or something like that. So all those things are going to be domain knowledge. And task knowledge, that is among the domain knowledge, we are going to have a particular task, how it's going to be done. So for example, domain knowledge is doctor, and task knowledge is used for the problem solving process. It's a diagnosis. And complete knowledge, the other type of knowledge is complete knowledge and incomplete knowledge. Complete knowledge always it's going to be a correct one. So that means, say suppose if you consider the people who are preparing for this civil service, normally they're going to have the complete general knowledge. That is the whatever is there in the book, that is going to be the this one. So it's going to be a correct knowledge that describes all objects, and always it's going to be a complete knowledge is a monotonic knowledge, or monotonic by that means monotonic means whatever we have, even if you add something to that, the conclusion is not going to be changed. That is, more adding knowledge does not change the prior conclusions. So generally, it's going to be correct. Incomplete knowledge, it's not always correct. Hypothetical knowledge, uncertain knowledge, ambiguous knowledge. So that is, it's only the incomplete hypothetical. So may or may not be. So we may say that there are people who are something like that hypothesis which we are going to propose. So that is going to be incomplete knowledge. People used to say, no, he is not good, that politician is not good, this film actor is not, something like that. So like that, it's only an incomplete knowledge. So these are the various types of knowledge mechanisms which we are going to have. So when you are going to create an artificial intelligence entity, the main task which is behind is the creation of knowledge base. While creating the knowledge base, we need to have the that is the information or the complete idea about what are the different types of knowledge and which type of knowledge needs to be stored, so that it's going to become an expert system. And there are strongly connected with formal logic and interfaces. That is, I also mentioned something called monotonic. Monotonic means which is always true. That is not going to be, which is not going to change, which is not going to change anything. That means always it's going to be a correct knowledge. Strongly connected with formal logic and interface, knowledge described in first order logic is complete. I hope all of you know this predicate logic, first order predicate, and propositional logic, and all those things. So normally it's going to be expressed in the form of first order, which is always it's going to be complete. Incomplete knowledge cannot be described using in general logic, and non-monotonic, that is adding knowledge can change prior conclusions. So adding knowledge can change the prior conclusions, that is non-monotonic. Whereas even if you add something, it's not going to be changed. We are not going to change the conclusion, that is monotonic knowledge. So that is about the knowledge base and knowledge types. So now we will see that representation, knowledge representation, how we are going to represent the knowledge, representing the problem solving world. So normally we in computer or we will be storing the concepts like this. The bird has feathers. India, New Delhi is the capital of India. And also sometimes we may say that sentences, yes, I am right. So like that, there are various sentences which are formal and which are going to be informal. How do we represent all those things? So the concepts related to the world, normally the bird has feathers. The objects and their properties, normally a Tweety has a red beak. Tweety is an object, which is what is the property of that is red beak. And a bird has feathers. That is, a concept is a bird, and related to the world is always all the birds are going to have feathers. That is the concept. And Tweety has a red beak. Red beak is the property of the object Tweety. And relation between objects, Sweetie is Tweety's child. Sweetie is also a bird, and Tweety is also a bird, and Sweetie is Tweety's child. That is relation. And relation between concepts, what is the this one? The bird is a concept, that is which is having feathers, and we can say that relation between the concept, that is a crow is a bird. So here the concept is related, that is bird, and relation between objects is child, and object and their properties is red beak, and the concept related to the world is the bird. So like this, we are going to have the various sentences and which needs to be represented in a formal and in a structured manner. that is by using some formal rules. So then only it's going to be called as a knowledge base, and which is going to be used to create this artificial intelligence entities. So let's make our own knowledge base. And also, I told you that while creating the knowledge or while representing the knowledge base, we're also going to use a term called meta knowledge, that is knowledge about knowledge, and inference management, how to infer priorities in inference, how to produce, how to proceed with inference. So knowledge about knowledge, that is, say suppose if you consider the book, any textbook, whatever the contents of this one, book, that is content space, that is meta knowledge about that book. That means we are going to have the knowledge in which page what topic is available, like that knowledge about knowledge. So procedural representation, the knowledge of how to solve a problem. Algorithmic, that is the meta, not well specified, so difficult to modulate, extend or transplant. And declarative representation, that is normally the procedural knowledge and declarative knowledge, what we have seen. So all those things are going to be represented using some algorithm and formally declared, used in the combination of knowledge base and knowledge base manipulation module, the core of most expert systems. So the production rules which we are going to use to create the knowledge base. So always it's going to be the set of rules. So that is if C1, C1, C2, Cn, then A1, A2, Am. That is axioms and the conditional part and action part. C1, C2, Cn is the that is conditional part. A1, A2, Am is the action part. If C1, then A1. If C2, then A2. Or if C3, then A3. Or if C1, C2, then A1. If C1, C2, C. So that means it is a combination of conditions or the in this one. And based on that reasoning or the conclusion is going to be the action, that is A1 or A2. And normally that is how the rule base is going to be formed, or rules are going to be formed, the set of rules in a knowledge base, so that it's going to work out the production system. And interpreter, once if you form the rules, how we are going to interpret that this one, that is going to be done by this interpreter, goes through the following recognize act cycle. So that first is matching. First is matching, second is conflict resolution, the third one is action. So interpreter goes through the following recognize act cycle. First is the matching. That means if C1, A1, C2, A2, or that needs to be matched. C1 and A1, C2, A2, C3, A3, or C1 is for C1, C2 for A1. Something that matching we need to do. Find a conflict set of rules that match the contents of the working memory. Conflict resolution. There is sometimes there will be some conflict. C1, C2, C3 yields to action A1. So in that case, either C1 is leads to A1 or C2 leads to A1, C3 leads to A1, or all of them leads to A1, or C1 plus C2 leads to A1, C1 plus C3 leads to A1, C2 plus C3 leads to A1. So like that, that is the conflict. Use a strategy to select one of the rules in the conflict set. That is to reduce that, that is to optimize or to reduce the search space, we'll be using this conflict resolution. And based on this, what action we are going to, what action, how the action is going to be performed, that is going to be the conclusion, or that is going to be the solution. Use the actions of the selected rule to update the working memory. So these are all the one is rule based production system, that is rule based and interpreter. And when it comes to the matching, as we have seen, matching, conflict resolution, and action, when it comes to the matching, the most expensive part is that matching. So because there is one to one to many to one, many to many, there are different types of matching is techniques or matching algorithms. The most expensive part, if there are W elements in working memory and R production rules with N conditions, and solving a problem requires C cycles, then WR and N into C unifications are needed. That means you can say that the value of W, the value of R, the value of N, the value of C, all those things are going to be multiplied so that it is going to have the huge search space. So matching is that's the reason it's called expensive part. And for that, again, to create this rule base, that is to reduce the conflict resolution and to create the rule, this one will be there is a rate algorithm. So normally, which is going to be used for this matching problem. Uh, I think this is the cell set theory which we have seen, A of x and B of x and C of x, which leads to D of x. Some reasoning. It's not that this one. Either it is going to be a AND or operation. So then the working memory for all those things is going to be the complete set. As I told you, C1, C2, C3, A1, A2, A3, like that. So this is the production rules. Three ways of operating the production system, starting with the condition part. That is, either it can be forward or data driven or bottom up reasoning. Starting from the action part, again it's a backward or goal driven or top down, this one. Bidirectional reasoning, so in both the directions it can be done. So normally the production rules is also going to be called as the means and analysis. So either it's sometimes what we are going to do, even the programming languages are also formed like this: top down, bottom up, or the hybrid one. It is both. Sometimes we are also going to use top down as well as the bottom up approach, like C sharp and other things. So, starting with the conditional part, bidirectional reasoning. So, advantage of this is production. Normally, the production rules are not going to be used very much in this one. Concise structure, modularity of the rule-based explanation function can be used. And there are various disadvantages also. Lacking in flexibility and efficiency is the most important disadvantage of this production rules. But most of the time we will be using this semantic networks, which is proposed by the psychologist, that is proposed by psychologists to represent the associative abilities. So normally we will be having a kind of associativeness which is going to be represented using this semantic networks. Knowledge represented as in the form of a graph is going to be called as semantic networks. Object and concept are represented by nodes. The relation between objects and concepts by directed link. You can see this sparrow is a bird. Here the concept is sparrow and bird, and sparrow is a bird. The relation between this is a relation. So there is this is a higher lower relation or abstract concrete relation. So sparrow is a bird. So that means the relation which, so like this, if you represent, it's going to be uh, like this. If you represent, it's going to be a semantic network. This is a higher lower relation. Sparrow is a lower relation or abstract concrete relation. Sparrow is a bird, lower one, and bird is a set, that is lower to higher. So that means it's a kind of higher lower relation. So semantic networks, say suppose we have seen a sparrow is a bird has feathers. So again, here this is a different relation. So normally sparrow, that is the name of the bird, which is name of a particular, this one is a bird, and a bird has feathers. This is a different, the a part whole relation. In the beginning, it is a relation. Here it is the part whole relation, represented by has a link or part of link. So the link is a form of whole part. So the direction is the opposite of the is a link. Sparrow is a bird and bird has feathers. So like that. So that means the second sentence, that means we are exploring the network. So it's called semantic network. So you can see this semantic network. Sparrow is a bird, bird has feather. The property of the birds can fly. Tweety and Sweetie are birds. Tweety and Sweetie are birds. And Tweety has a red beak. Tweety has a beak which is of color red. And Sweetie is Tweety's child. Sweetie is Tweety's child. So that is a child of relation. A crow is a bird, and birds can fly. So this is see, all these are going to be called as knowledge. So we have a knowledge birds can fly. We have a knowledge a crow is a bird. We have a knowledge. So how we are going to represent this in the knowledge base? So this is also one of the mechanism that is called semantic network. So based on this semantic network, that means there will be a reasoning mechanism. So which birds can have red beaks? So by seeing the semantic net, we can say that Tweety is the bird which is having red beak, and directly match of subgraph. Can Tweety fly? Yes, because Tweety is a bird, bird can fly, so Tweety can fly. So following a easy link from Tweety to bird and the property link bird to fly. So this is process. Normally you might have remembered inheritance in the object-oriented programming concepts. So that is how this inheritance is evolved. So that means the semantic networks is a graphical representation of the property, concept, object, and all those things by using the various kinds of relation. This is also one of the knowledge representation technique, internal representation. So there are some advantages, some disadvantages of using this semantic networks. Simple representation, easy to read, association possible, inheritance is possible because of the semantic networks. The disadvantage is a separate inference procedure must be built. So there are for this there is separate inference procedure to be built. The validity of the inferences is not guaranteed. For large network, the processing is inefficient. So that means, say it is only some 5-6 sentences it is possible, and if you are going to have say of 20-50 like that, then it's going to be an inefficient, that is in representing the semantic networks. So this is one type of knowledge representation techniques. Uh, so before that, we will go back to this logic is also one knowledge representation method, and it is powerful method. Always will be using this knowledge and knowledge representation techniques. Most generally, it is going to be used. And again, there are first order. Normally, if you have read set theory, you are going to have the knowledge about all these things. Variables, normally it's going to be used in small a, b, x, y, z, and constants, function symbols, fg, predicate symbols. Normally we'll be using the PQ, and the various operators which we are going to use, the negation, conjunction, disjunction, implies, universal qualifier, and external. That is, there exist for all symbols. So in the case of first order, the word is represented in the domain D. So I hope all of you know all these things. That is, say how we are going. Say this is the natural language. Birds have feathers. How we are going to represent this using the knowledge representation technique. So that is for all birds have feather. That means all birds are going to have the feathers. For all X birds, X has feathers X. So X is a variable, and for all is an qualifier. Has feathers is a relation. So birds have two legs. That is for all X birds, X as number of legs is equal to X. All X, that is any bird is going to have two legs. So that is whatever the value we are going to pass for the X, that is so that is going to be have two legs. Tweety has a red beak. That is beak is a property. Tweety and red are the this one. So an injured bird cannot fly. So for all X birds X and injured X cannot, that is cannot, negation of fly of X. Everybody loves somebody. So that is every means for all X. Somebody means there exists Y. Loves X comma Y. There are places in Japan where it never snows. So there are places, that means there exists X in Japan where of X, and negation of, that is never snows, negation of snows of X. So like this we are going to represent. This is also one of the knowledge representation techniques, that is first order logic, predicate logic. We are going to say this. So again, here we are going to use this deductive inference and inference, the various inference rules, modus ponens, etc. So if P and P, if P and P implies Q, then Q can be inferred. So that means if P is true, then P implies Q, that is it's true, then Q can be true. That is like this. All crows are black. All crows are black. VT is a crow. Therefore, all crows are black for all X, Ravin X, block of X. Ravin is VT, that is name of the this one. Therefore, block is VT, that is VT is black. All crows are black, VT is a crow, so VT is a black, like this, the deductive mechanism which we are going to use. So that is the first order logic. Again, there are various axioms and theorems which we are going to use. Don't want to go in depth of all these things. Just I would like to mention the different knowledge types. No need to make the difference between knowledge representation and inference method, and soundness of false statement, soundness of false statement. 1 second. No need to make a difference between the knowledge representation and the inference method. Soundness, that is a false statement, cannot be derived, and a completeness, all true statements can be derived, has a logical makeup. And there are certain disadvantages that the derivation takes a lot of effort, difficult to use different layers of representation. So this is the first order logic, and we're also going to use this Prolog to do all these things. The programming language Prolog and Lisp. Normally, it's logic programming is the Lisp which we are going to be used in the AI, but nowadays all these things are going to be replaced using the Python. So these are all the logic programming. So these are all the knowledge representation techniques. Before that, just I would like to give a free demonstration, because you might have got just I will skip this sharing, and I'll demonstration. Which is available in the YouTube.
Sir, voice is not coming. Sound effect is there.
Yes, sir. It's not coming.
It's not, sir.
Okay, 1 second.
I think because of headphone, I think maybe.
No, it's not coming, sir.
No, sir.
Not audible.
Now it's coming. Now it is coming, sir. Just increase the volume, sir.
Yeah. Come. Not audible, yeah.
Sir, I have increased the
Breakup audio, not audible. Audible problem. Audio problem. Isn't it audio problem? Demo is not audible.
Sir, it's
Sir.
Sir. Hello.
Sir, audio to be volume
It's
to
not
be given,
audible,
sir.
sir.
Volume to be
The
increased.
volume I have increased, sir.
Not audible.
Not audible.
Not audible.
ನಿನ್ನ ಬ್ಲೂಟೂತ್ ವರ್ಕ್ ಆಗಲ್ಲ. ಹಾ
Okay, sir.
ಹಲೋ ಸರ್. ಹಲೋ,
Hello, sir.
is it audible, sir, now?
Yes, sir.
No, sir. Just explain. Explain.
Yes, yes, audible.
I think it is not audible. Audible, sir.
Audible.
Just increase the volume, sir.
Sir, that is the maximum.
Okay.
Okay.
I have solved for Swami. Drama, na? Not audible.
Sir, from my side, it is correct. You can increase your space, this one, so all there.
Professor Shekhar, sir, effect is there?
Yeah.
No, you have to increase your volume, sir.
It is maximum is there, sir, here. Headphone.
Now it is clear.
You can check with it.
It is clear,
Ah.
Professor Pawan.
Okay.
Thanks.
Okay, sir. Hello.
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 Hold on, sir. This demo this video.
Hello, Professor Pawan.
Yes, sir.
Professor Pawan.
Yes, sir. Hello, sir.
Demo screen is not audible.
Okay.
Sir, it's completed almost just a minute.
Okay.
Okay.
Okay. That is the.
Hello, sir.
Sir. Somebody else is also talking, sir. There is some disturbance.
No, sir. Nobody is there.
Yes, sir.
Nobody is muted, sir. Everyone is muted.
1 second.
You can share the screen, sir.
Okay. One second, sir.
Shared, sir. Screen is shared, sir.
Sir, there is somebody. Hello. Sir, I'm audible?
Audible, sir.
Okay. So that's what about the internal representation and what we have seen some kind of demonstration about the 10 different applications of artificial intelligence, which are going to be very much effectively working at present in this one. And because of this AI and artificial intelligence and its evaluation and the techniques and the mechanism, how the future of work is going to be in future. So whatever the work we are going to do, how it's going to be affected, and what are the things. So when we started our this one, normally we used to have one to one, one to many. That means one person used to have when we were students. That means in the beginning there was one computer. Many people used to use that one computer, and afterwards one to one. One person used to use one computer. Later on, that is first is one to many, next one to one, and afterwards many people. Sorry, one many computers are going to be used by one person. So that means we may have one laptop, one desktop, one mobile. So all those things are going to be used by one person. That is the present situation. And also we have the many to many. That means many gadgets are going to be used by many people through a network or this one. So like that, all these things are happening. That is because of this. So in this scenario, what is the workforce, how it is going to be, we'll see that. Now that is called the pervasive computing era. We are entering the entering a time of great promise and that is peril. That is a digital transformation to contribute. That is something like this one. So the only skill that will be important in the 21st century is the skill of learning new skills. Everything else will become obsolete over time. That means in this present scenario, always that is the skill of learning is the most learning new skills. Then only we can sustain in this industry, that is IT industry. So that in the future, as we discussed from the morning, industry in the middle of massive disruption. So that is the present, this one demand is increasing rapidly for emerging technologies like big data analytics, artificial intelligence, machine learning, cyber security, IoT, and robotics. So that is out of this, just I think in this that is STTP, you might have covered most of the concepts of this. So our goal is to position India as the talent hub for the new emerging technologies. For that, we need to build a talent pipeline for the future and enable existing workforce to get reskilled. So reskill or perish. That is the this one. So every company will need to navigate this change. That is from skill to reskill. Need a collaborative industry level response. This industry driven learning ecosystem is future skills, that is by the NASCOM. And there are various techniques which are going to be considered as future skills, that is big data analytics, artificial intelligence, cyber security, robotic process automation, internet of things, social media, cloud computing, virtual that is reality, augmented reality, virtual reality, and 3D printing. So these are all the things which are going to have considered as the future skills, which are going to have various job emerging job. This one. So because of that, the job roles are also going to be changed. So if you're in good at data, big data analytics, data scientist, data architect, data administration, analysis, analyst, business intelligence. So artificial intelligence, again, the data architect, applied scientist, machine learning, speech vision, analyst, BI, DevOps engineer, something like that. And cyber security, analyst application security, and consultant network security. Like that, the in future the roles of the job also going to be changed. So 10 years ago there were no social networks. We never used to have this Facebook, Flickr, Twitter, and WhatsApp, something like that, even YouTube. But now and 10 years ago there were all these things were not there. And 15 years before that, we did not have the web itself. That means when we started our this one in during 2005 or 2000, most of the internet facility itself was not there. We did not have the web. And if you work in the web programming, online marketing, or mobile phone industries, now it can be done for your job is did not exist 20 years ago. So at present, if you are working in this web programming and online, all these technologies, and this kind of jobs were not there earlier 20 years ago. So in future also, whatever the job we are doing now may or may not be there in the future. So we know what jobs will exist 20 years from now in this artificial intelligence scenario. Sorry. So some people, the people out of work today will soon find jobs again. So that means nowadays it's getting job is not difficult unless until if you have a good skills. And but the work won't be the same. We'll soon find a jobs again, but the work is going to be different. So that means always we have to what is the future of work. So that is it's not that just we have to sit in a place and do the work. It's going to be dynamic in nature, and it's going to be more transparent. The future of work is going to be transparent in nature. There won't be any corruption. There won't be any delay in this one. Everything is going to be transparent. No one is going to just take your word for it. In the past, productive was difficult to measure. And that means just we used to have the clerical and other things. It was very difficult to measure the productivity, but nowadays it is very easy because of this technologies. And business wasted millions of dollars every year paying for employees downtime. But now that is not time and task tracking tools are revolutionizing the productivity measurement. So each employee's work can can be directly tied to the bottom line. That means how much your what is say directly it can be linked. So how much what is the productivity can be measured day to day, and based on that perks and pay can be linked. The more productively you work, the more money you will make. So the future is of work is flat. That is, no one is going to complain about their commute. And so suppose if you consider a simple example in real estate, the mantra is location, location, location. But at the work, the mantra is communication, communication. That means in AI or whatever the knowledge that we have, here is only the communication, how effective it is going to be. So work used to be considered as a place earlier, but now the work is going to be the only option for communication where landline phones earlier. But now today the project teams use amazing web tools to work together from anywhere in the world. So all these things are possible just because of this AI and other technologies. So tools like Skype, Zoom have made long distance calling virtually free. So because of that, the world, we can say that the world is now flat, but the organization itself is flat. So call centers used to be massive offices built in rural areas or countries like India, but in 2000, JetBlue started a revolution, allowing 700 customer service reps to work from home with no central office. So now that is what is giving the results like during this pandemic COVID time. Yes, and also whatever the virtual STTP we are conducting right now, the place is not the constraint. By sitting anywhere, any time, you can deliver the things. So in the future, the location will not matter. It is only the scale. The future of work is competitive, and no one is going to pay you just for having a degree. So the percentage of Indians with a college degree is growing. So that is now it's almost GER is going to be 29%. Is the and the formal education is more accessible than ever. And academic earth, there are whatever the lectures and videos and all those things are available from the top universities like Stanford and MIT. So there is no longer an excuse not to know how, and we can there won't be any excuse. This is naturally for the students and whoever is going to be an aspirant for the job. We cannot say I don't know, because everything is at the fingertips nowadays. So competition for jobs is no longer limited to where you live. So it is a common place to hire vendors and contractors from across the planet. So, so one is our organization plans to increase spending outsourcing by 25% more on this year. So like this, the technology is going to be changed. In some cases, your competition is not even limited to other individuals. It is across the globe. So to split a task into similar pieces and unleash into millions of people around the world, it's going to be called this one. So say if you consider this Wikipedia, 13 million articles are all written and maintained by the crowdsourced. All this is also again an application of this artificial intelligence. And Threadness finds t-shirt designs to sell from submission and voting by the crowd. And reCAPTCHA is also one of the AI tool. So multiple projects are currently digitizing physical books, but computers cannot always decipher the scanned text. So here the reCAPTCHA is the one which is going to digitize the old documents and and the physical books. So reCAPTCHA works by presenting people with two words to retype when they go to the create a new account on a partner website. The first word verifies that you are a human. The second word is from a scanned book from that a computer could not read. So that is whatever the for the security purpose, the reCAPTCHA puzzles are solved each day, roughly around 2,200 millions. Each one takes about 10 seconds, but in total they amount to over that is 150,000 hours of work every day. So all these things to stay employed in the workplace of the future, you need to stand out. So the future of work is on demand, not like this one. Because of this AI technology, no one is going to guarantee you a lifetime career, not like this government jobs and retirement after 60 years only. So each and every day is going to be a competitive because of this artificial intelligence and its evaluation. And many businesses are choosing contract relationships or hiring new employees. So the word career is as outdated as the word typewriter. We cannot say that the career, my job. So it's only an outdated one in future. Project teams at work are beginning to resemble movie production teams like this one. Independent individuals with unique talents get together to work on a company project. So here you can see this unique talents only will get the jobs. At the end, they will go their separate ways. They might work together again in the future. They might not. So always it's going to be a virtual teams, a group of individuals who work across time, space, and organizational boundaries using collaboration technology. So if you consider in 2016, more than 28 million Americans worked in a virtual team at least one day per month. So now it is going to happen in our country also. By 2000, the number will grow over 100 million. So although home is still is the most common location, millions of virtual teams members work from just about anywhere. So that is just possible because of this AI. It is a whole new paradigm. So why should you consider for this? Because the future of work is transparent, flat, competitive, on demand. So this is all these things can be achieved just because of this technology, artificial intelligence, I can say. individuals will have more freedom and power than ever before. Your earning potential will be based on merit, not based on the location. Say, suppose if somebody is in Chittor or somebody is in Bangalore, normally we will say that the Bangalore people are going to get more salary, but that's not going to be the thing. So it is based on merit, not by location. So employers will have access to a longer and more skilled workforce. So because the future of work is you. So this is changing how the world works. The artificial intelligence is changing how the world works. This is just the future of workforce because in this artificial intelligence era. So this is about my presentation of today. Mm. Sir, Pawan sir.
Yes, sir. Thank you, sir. Thank you very much. So you have taken your valuable time. So we have taken. So thank you so much for coming and given your valuable knowledge and shared with our all participants.
Now the participants are
Participants,
less now, sir.
I think, yeah.
Morning, the
So
number
I
of
have shared
participants were
the
more.
feedback. Yeah, I have shared the feedback link to all the participants. Please kindly, carefully fill the form and submit it. So today's session it is over. Thank you once again, sir, Dr.
Thank
Hanumatappa
you,
sir.
sir.
Thank you once again.
Thank you. Thank you, sir. Thank you for giving me the opportunity, and also I thank all the organizers as well as the management of the college. And also, I would like to thank the participants for their patience listening, especially sitting for long hours is very difficult, and also the online talk understanding is also going to be very
Okay.
much difficult
So
because of this
there
again
was a
the
yeah. Thank you,
technological issues.
thank you, sir. Thank you very much, sir.
Thank you, sir. I'm leaving now.
Thank you, sir. We are leaving
Thank
the
you.
session.